Last unit was trigonometric functions and their graphs, so sine and cosine graphs. We did the multiple choice, or we didn't actually do these multiple choice in class today. The answer key is posted online. If you're stuck on any of them, send me an email. We didn't finish the unit, so if you look at the multiple choice, you guys don't need to do number 10. We didn't get there yet, where we only spent one class on it, so I don't think it's fair to put on your midterm. And question 11 is also not going to be on your midterm. We are going to do it when we get back in February. So the only two questions I'm doing today is question 12 and 13 in Unit 5. I love a good word problem, and we didn't really get the chance to have any nice word problems so far in this course. A mechanic rolls a wheel of radius 42 centimeters, and the wheel rolls a wheel of radius, and a wheel as it rolls makes a 1 revolution every 2 seconds. That was really confusing. Yours is going to make more sense. The diagram below illustrates the vertical motion of the position of the wheel over time. Find an equation of the function shown as a transformation of sine or cosine. We are going to do both right now. Make sure you read the question. It could say you have to do cosine. It could say you have to do sine. Totally up to you. So, big thing that I see is that it has a radius of 42. If it has a radius of 42, we know that goes from the middle to the top, the middle to the bottom, the middle to the side, up to you. But something that tells me about my graph is that it's the amplitude. Okay, that's a nice little question. So this would be the amplitude of my graph because it goes to the middle of the top, which is the definition of your amplitude. Beautiful. Come up with an equation. Let's start with sine. Now, if your amplitude is 42, your midline is right in the middle of your wheel. The distance from the ground to the top is also 42. So the entire distance from top to bottom is 84. In this case, your midline is also 42. It's in the middle of the wheel. Bottom to top is 42. Middle to top is also 42. A little bit of a coincidence that happens when I'm dealing with wheels. So I know my A value is 42. I also know that my last value, I think we did D's in this course. Did we do A, sine, B, x minus c plus d? Or we did K's and H's? Totally up to you what would make your life easier. I'm going to do C and D. I think that's what we did. I also know my D value is 42 because that's my midline. I'm really wiggly today. So two things I know right off the bat, and that fits for both of my equations. So I know y is equal to 42 sine plus 42. My B value comes from my period. We know that my period is equal to, we're doing it in radians, 2 pi over b. I don't know my b value. We do know our period. If you jump up to your question, it says the roll makes 1 revolution every 2 seconds. 1 revolution, 1 wavelength, 1 period. You have 2 equals 2 pi over b. If you reorganize this, you get 2b equals 2 pi, which means b equals pi, because those two cancels. So here, I got a pi. Big thing is your phase shift. You know that sine is in the middle, going up. That's where I base my phase shift off of. So the first one is right here. I know my one rotation is 2. So what would be the distance of this middle going up? Halfway from 0 to 2 is 1. So your phase shift is x minus 1. Beautiful. That's your sine graph. Most of your values are the same for cosine, so your amplitude is still 42. I have a cosine instead of a sine. Your phase shift is actually different, but your period's still the same. Your midline is also the same. Phase shift is different. Jump up here. Cosine, you go off the top of the graph. Halfway between, we said this was 1 and 2 is 1.5. You can put a 1.5 in there. I'd be okay with that. 3 over 2 would be nicer. I'm okay with 1.5. So up to you if you want this or if you want that guy. Make sure you read the question. It might tell you you have to do sine. It might tell you you have to do cosine. That would be important because if you did the opposite, you would lose some marks. Beautiful. Okay. Question 13, last for me for the evening. Sketch a graph of the function First thing I see is that this 1/3 has to move. When I move it, I times everything by 3. So I have y equals 3 cosine everything on the inside stays the same. And then same thing, I times by 1 over here. Gorgeous. So a lot of stuff just comes out of that. Your 3 value out front is your amplitude. Your midline is -1. Your period is, see how that has a pi over 2? Your answer got to be in radians. 2 pi over your b value, a half, which is 4 pi. And your phase shift is pi over 2 to the left. So you could use this method and draw it. I don't like that method as much as I like a mapping rule. So I'm going to do the mapping rule a little bit lower. It is a cosine graph. Cosine graph has these key points: 0, 1, 90, 0, 180, -1, 270, 0, 360, +1. You have to memorize those, or you can plug it in your calculator if you know it goes up by 90 every time. I'm going to make a mapping rule. XY goes to, on the inside I have a half, so I have a 2 here. I have an x plus pi over 2. I'm going to do a minus pi over 2. Let's change this to a 90 for now and then change our final answer to radians. Then I have a vertical stretch of 3 minus 1. So plugging all these points into our mapping rule. 2 times 0 minus 90 is -90. 3 times 1 is 3, minus 1 is 2. Does that make sense? Am I losing my mind? No, looks good to me. Same thing. 2 times 90 is 180, minus 90 is +90. This guy, same thing with the y value, is -1. And if you keep on keeping on with those points, you are going to get 180 goes to dun, 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 dun. 270 minus 90 is 180. Did I skip a point? I feel like I skipped a point. Oh, yeah, I did. No, I just plugged it in wrong. 2 times 180 is 360 minus 90 is 270. Sorry. That guy goes to -4. And keep on keeping on. I have 270 times 2 is 540. 540 minus 90 is 450, which is -1. 360 times 2 is 720. 720 minus 90 is 630. And this guy is back up to 2. So you could go ahead and plot these points now. I'm going to change them back to radians. So -pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. These were nice because they're all from my unit circle, or most of them are from my unit circle. And then you can plot those on the graph. So I am going to say that each block is pi over 2. So this is -pi over 2, or -90, which has a height of 2. This is going to be +90, which has a height of -1. Then I jump over 2 blocks later. I am at 3 pi over 2. You can do all these in degrees and then change it back later as well if you want to. 1, 2, 3, 4. I'm down here. 2 blocks later, 5 pi over 2. I'm back at my midline. And then 2 blocks later, I'm back at the top. 7 pi over 2. Right here. So you have one full wavelength. The question will say that you need 2 cycles. Usually always says 2 cycles. It's right there. So you can keep going. This was 7 pi over 2. This would be 9 pi over 2 is at -1. This would be 11 pi over 2 is at -4. 13 pi over 2 would be at -1. See how it's following that pattern? Each top is increasing by 2. And you can go the opposite way. -3 pi over 2 would come down to -1. As long as you have 2 cycles some way. Everyone's graph might look slightly different. You might decide to go left. I decided to go right. Totally up to you. Beautiful. Big thing, make sure your final answer is in radians because your question had a radian guy there. Last question. We're finished. Great. Oh, it says state the amplitude, vertical displacement, phase shift, and range. I already did most of that over here. Yeah, I did all of that, I think. Only thing I didn't do was range, which would be your minimum, -4 is less than y is less than your maximum, which is 2. Okay? Gorgeous question. Really like it. Okay, send me an email if you guys are studying and you're stuck on anything. I will try my best to answer. I'm going to have math help at 11 o'clock on Monday in my room. There's an English exam right before that in my room, so be quiet if you're waiting outside the door. We do have to be patient for them to finish, and then you guys can come in. I'm going to try and stay until around 11:50 before I go out and get my lunch. So, awesome. I will see you then.